Hello beautiful people, nice to meet you again. So today we are going to try to build something like that. It should be like mid-level of complexity, and we'll cover some velocity field, we'll cover some Vellum with this bubbles pop network, masking our blending our materials between two of that, and maybe doing this one as well. This is a plane with stamp material, so dive into the Redshift and eventually we should have something like that, right? Let's create a geometry container, dive that in. I prepare some object to work with, so I'll just grab the link. And here you could imagine that could be a bottle, that could be anything you want. Let's use match size. Okay, scale to fit, space H, and to center your object. Basically that's it. It's like a grid 1-to-1, I think, and reasonable scale. The next thing I would do is giving that normal, just a good measure for the point, and we will use this normals down the stream. And then the basic idea of that is having the velocity that will grab something underneath our main object and drag that in. Then we have this swirling motion around the object and then going back to the top and up. So we want to somehow to control this field and have difference during the duration of the object, if that makes any sense. So create an attribute triangle, that should be a point triangle, and start with just general vector, and I will call that ups, because up is internal vector or something like that, but just to differentiate I will use a set 0, 1, 0. So this vector is just points, and vector points up, and to prove that we could use normal and equal to ups. So this way we break normals, but we could see that these vectors are pointing up. So the next step, we need another vector, and we'll mix between these two, and they will swirl around our object. In order to do that, I will create another vector. I will call that around. That will be equal to cross between normal and up. So the cross section function, okay, it's ups, and we could update our normal just to investigate the direction of our new vector. The cross section is like a vector between two vectors, and if you imagine that these two vectors is generated in a plane, something like a grid, this new vector around always would be perpendicular to this grid. So in this case we have something like that, and if you want to change the direction, we could change the order here between normal and ups, so that way. This is all great, and we want to mix between these two. Basically, one is up and one is turning around, and for that we will use, I could potentially use just normal, and we could use a lerp function. We give this function two vectors, which is ups and round in our case, and we give it a mix value. This is a float value, should be between 0 and 1. That mixed value will determine how much of this vector or that. This is like a threshold between these two. So to do that, we could use a float mix equal to channel float for now, call it a mix, and create this channel pressing this button. So now, if we update our normal, we could kill this. We could see that we successfully mixing between these two. So between round normal, again, this is 1, mixing toward this end around, and this is 0, mixing toward this vector ups. But now what we want to do is somehow changing our vectors based on the normalized size of this object. And we have it. We have a great and useful vector box function, call it real bbox, I think, right? And this real bbox give you a normalized vector in all the direction. So we want to use 0 and b, right? And if you just forgot what you need to do, you could place your cursor at the beginning of the brackets, press space and back, and now you could see that what this function about and what you need to use in order to work this properly. So geometry and vector position, and we use geometry is 0 incoming input and position. So what we could do with that, we could use in the mix, instead of our float, we could just cut that and use it below. We have the order, and for example, we could take our box and use one component. So now you could see it is like 0 to 1, 0 is ups, so we have one up vector, and 1 is around. So on the top of the object you have swirling motion, you will have a swirl motion. For now we use it only a normal just to visualize our direction, our vectors. And we could go one step further and create a channel ramp. And call it mix, and we'll use this Y component of the bitbox in this way. If you create this channel and use this channel ramp instead, so we have already updated our mix. So press this button and you have something like that. So now, as you could see, we follow our we control our vectors with this ramp, and the good thing about that is channel ramp return you 0 to 1 float, which is great for LERP. So I want something like going up in this portion. I want swirl motion in the center. Again, I could sculpt this vector basically real time. I want up something here. I want again swirl motion and up with swirl at the end, something like that. I could select every point with shift, right click, and use something like B-spline to have a more or less smooth interpolation between the points. Okay, a little bit of tweaking. Okay, so we successfully create our vector field, and now we could call it v at v, which is vectors, and we have basically the same but for vector. Now we could use let's call it creating v, and we could use it for further manipulation. I would like to use it for VDB from polygons. I want to create a density field, or not a density volume field, with the vector of V, and I would use it to advect our particles and Vellum simulation. So create a vector VDB from polygons. Let's give it more resolution. I will use a surface. I could press this button and pick point velocity. So this will give me velocity field V, as you could see here. And let's use field interior and give much more exterior band voxel. So now voxel is like a 3D pixels, and exterior band voxels is like how far that will extend our voxel tree outside of the object. So now you have this VDB from polygons. You could create your point velocity. You could do the same basically with VDB activate and so on and so forth, but we'll shorten that process as well. In order to visualize that, let's use a point from volume. And trail volume. Okay, let's create a few points. I will use this one. I will give it a little more points, not that much. So trails, velocity, and here we have it. So now you could see visualization of your velocity. This trail is visualize your velocity. So now you could see we have this upstream, then swirling motion, and again upstream. Let's create a null. This is only for visualization purpose, so let's call it out velocity. Okay, let's go further and create object merge. Let's do this side. Let's grab it and paste it here, and we have our let's grab this one, right, with normals. So we have the same object. Now we want to wait a minute. We want to create a cube, and we want to go with Vellum balloons and Vellum bubbles to suck into this object. And this guy is just only for visualize where the object is. Right, let's create a transform. We have a box and we have a transform. I want, there will be a source for our bubbles. So I want to transform it somehow. I will use this guy, this guy, this guy, just in arbitrary numbers. We could rotate it. To be honest, it's not a good idea to use it here, but now when we determine our shape, now we could use a transform. Oh, okay, something like that. I want just a pivot point to be in the center of the object. Something like that, okay? Now we need to scar a point. And I want to scar just one point at a time. And I will change, basically it should be here, scar. So let's grab a frame. Let's do a model of 10 equal to 1. This way we could have point every 10 frame, right? 9, 11. So we start with 0, 1, 11, 21, and so on. And obviously I need to change the seed every frame, so we have the point in different spots, right? of this box, and after 120 you don't have anything. Right, now we want to scarab, copy the point, points, and you want a sphere. Let's use a polygon, which give you like triangulated mesh. Let's give it more frequency and do this. Your points here and there, so, and you want to create a different p-scale for each point. So create true triangle just before square, because after p-scale based on pt now. After a scatter you only have one point, and that will give you only one number for pt now. The rand function will give you numbers from 0 to 1, so you want to fit 0 to 1 between two new sets. So you could see now we have smaller and bigger bubbles all over the places. Right, let's create a Vellum balloon, configure balloon. It will give you two nodes, pretty standard Vellum cloth and Vellum pressure. Let's plug that in. And now if you use a Vellum solver, what you will have, okay, press escape and go to the first frame. What you have here is only the first frame of your simulation, and that is it. But I want to bring somehow every step our new geometry to the Vellum solver. First, go to the forces and kill the gravity, and go back to your Vellum close. I will leave it as a default. Just usually I want to increase your damping ratio, because this damping ratio is like dragging some weird stuff out of your, like weird velocity or jumping out of your simulation. And if you want, you could play with stretch and bend stiffness. These two is like the main drivers. Stretch is like how stretchy your material is, and you could increase it, and that will give you more stiff material, or decrease it and that will more stretch your rubber toy. The same go with the bend. It's like the bend in between no polygons, something like that. So if you want more bendy and more wrinkly stuff, you could lower this number as well. So for the Vellum solver, in order to work it properly, I want to incite the source, and I want to use a Vellum source here, because this inside is a DOP network, and that will give you an ability to do it each frame. So emission type, here you have only once, but you can change it to each frame, and that will require soap path and constraint soap path. So let's go back and create two nulls. This is a 0 for the geometry, and this is for the constraint. And to be honest, I think you could do it without this connection, but just for the visualize connection, I will leave it as it is. I will copy geometry and paste it here, soap path, and go back and I copy this cont null and copy it here at the constraint path. So now all you have to do is connect these two and see that we have something at least, right? Maybe you want wind, pop wind, and you could use all the pop nodes here, pop network from the pop network, and connect it to the force. If you give it some wind up, right, and you could see that we successfully have that. And it's beautiful, to be honest. But we'll not use a pop wind. Instead, we could use a pop advect node, advect but volumes, by volumes, right? And again, you need to specify your volume, and we will create it here. So just copy out velocity, go inside and paste it here. I want to update the velocity or maybe a position, I'm not sure. Give it a final velocity and trace. This is more accurate. And we have nothing. You could give it a advect by velocity, but it will not work because we have this field name conflict. We have a Vellum, velocity, sorry, and here we have a V. We either need to rename it here or just simply go inside and change that to V. So now you could see something at least. Right. And in order to see everything just in the proper way, we want to basically template this geometry and try to see what we got. Yeah, we have up velocity from here, then we have swirling motion, and then these bubbles go just upper and upper. Okay, let's use post Vellum process. You could press J and just connect. You have the same connection, right? It doesn't work, I'm not sure why. So now you could give it a little bit of blue, give it a loop. This is best for triangulated geometry. And the next thing I would think of is giving it collider, because now we penetrate our mushroom and we need to collide with something. Right, now it's working properly. And to be honest, I like even more this version because we have some pretty big bubbles. Obviously, to my eye, I want to lower the velocity scale in this case. Some weird stuff. Just go outside, try to update your viewport and flag it as a volume solver, because it's like a conflict of the viewports. Okay, I have this motion on the top, on the bottom, sorry, and then I swirl around our object, and then when we reached the top, we're again flying away with the velocity. I will assume that that will stop. Let me see, because we have no velocity here. Our field is stopping, but I don't care in this case because I'll pick some camera angle that we'll not see. Right, let's use a file cache. Call it something like Vellum, because I have something there, and save to disk. Okay, we have everything in place. We could see what we got. I like that. It's fairly simple Vellum solver, Vellum animation, so we don't need to increase substeps or constraints. You could play around with that as well, giving more interest with Vellum inside and pop wind and pop noise and so on and so forth. But for this case, I'm happy with that. Let's create a null. Right, call it out bubbles, and let's go and create. Okay, let's move it here. Let's do some beautiful. Let's go here and grab this object again, and basically I want to grab our bubbles, this branch. Right, so now you can see we have mushroom and bubble. What I want to do now, I want to create an attribute for the mushroom and call it mask equal to 1 or equal to 0. And the same I will do for the bubble, but before I will obviously delete everything that I don't need it, because we have a lot of attributes and I don't need pretty much anything. Okay, mask. This is mask as well. One something, and for this I want to give it a 1. So now I want to transfer our mask from here, attribute transfer, to the geometry, and I will use this mask as the mask for our shaders. So in order to see that, we could right click, go in here and click mask. We don't need primitives, we need mask attribute, and we should see something at least. But for now, I see nothing. Let's go here. Let's lower the threshold, right, distance, and give it a little bit of blue. Basically, we could use 0 and very low number here. And as you can see, this mask will depend on the subdivision of your geometry and polygons. So let's try to use a subdivide node, and that will give you a fidelity for your mask a little bit. So let's use loop, maybe, or leave it as it is. And that is great to me. So right, but now we see that our mask is following our bubbles, and I want to accumulate these values somehow. So in order to do that, we use a solver, and we'll use this transform inside our solver. So let's connect these two. Let's go inside and paste our transfer attribute. So we want the previous frame is like a mask, and I want input number 2. And basically we could create an output node and see our mask, and this is exactly what I want. So we accumulate every frame and have this mask where the bubbles is touching our geometry. It's not super precise, and potentially you could lower this number, so that will give you a little bit more precise value, but I'm okay with that. So we have this magic effect, and this is okay. But what I want as well, I want this mask to fade somehow. So I use an attribute triangle and create a mask attribute, or I'll use mask attribute, and I want to multiply it with some very low to the 1 number. So each frame, this multiplication will apply to the number 1, and this will lower our mask during the time. So let me show you what I mean. You have your mask, and with time it's fading out. And basically that is what I want. I want to have some freezing material, and then it will disappear during the time. That is great. So now what I want to do, I want to create 2 particle systems. One is from bubbles, and I think it's like here. Let's call it bubbles. We'll use it, and let's call this mushroom, so you could see what is what. And another is one is for bubbles, which will generate it from the bubbles itself and moving at the same time along our vectors that we created previously here. And another particle system will be generated from this mask attribute. So let's do the first one first. Let's create our pop network. Go inside, give it a space. So we need scatter into the surface, and Let me see what we got, right? And this is because we don't want to use a guide to see the guide. Then we go to the purse and lower this number. Particle per second. It's okay, but to be honest, I don't want to inherit that much of an attribute velocity from the bubbles, right? And I will give these particles different velocity. So let's start with a pop wind. It's like general interest to the moment, just a bit of amplitude. I'm not sure what the scale of this scene. It will depend on the scale of your scene, something like that, and maybe even lower. So we could see like a trail. I don't need this much of the movement from this particle. Right, this is the magic little bubbles. Right, the first thing I would like to grab our velocity from that mushroom that will create in the wrangle. So in order to do that, I will use pop inside our pop network, and I would like to determine inputs. I'll use SOP link, and I need to grab this one out. No, this wrangle. Okay, control copy, go inside and paste it here, so you have the ability to link it here. And what I want to do, I want to add to the existing velocity something, right? So I grab a velocity because I have something already, and I want to add some numbers out there. First, let's create x, y, z distance. We need second input, our position of the current particles, and then we need to prim primitive attributes, or prim UV. Again, we'll use the same output, number 2. We need primitive, and we need a primitive UV. And here we want to determine is a V, because we want to grab velocity. We need to add it to the velocity. Let me see what we get. And we have something, right? It's cool. Probably I want to multiply it with a constant, just to calm that down a bit, because it's too much to my taste. Okay, let me see what we got. Right, you could lower that more, but we'll have different behavior based on the next thing we will do, and then we could manipulate with multiple constant. Now let's grab a min position. Okay. Yeah, we could use the second as well. The position, and that will give me a minimal position of the particle to the geometry, and we could update the position. So now you see that you only allow your particles to be on the surface of your object. But I not just want to do that, and I have this max distance. Sorry, not max distance. I want to mix between these two, and we could use a mix node, grab your already position that you have, then you can grab your minimal position and add that to the minimal position. So now you have both of two worlds, something like that. You have some threshold from the surface, and that will be controlled of your parameter. In this case, what I like to do is create a parameter and grab that on top of this network, because it's like inside of pop network, inside of pop VOP, and there's not weight. Let's call it mix, label mix as well, and let's go back. So you have this mix value here, so you could control it from the top. And basically you could do it online. Now when I'm happy with this particle system and it's okay, maybe I need to lower the life expectancy now and life variance 0.1. I could give negative and back, interpolation, just prevent that from stepping. Maybe it's okay, I'm not sure. Let me see if I have a mushroom here. And I like to examine it when we have everything merged together. But it's okay to me. Maybe, just maybe, let's increase the constant now, because I want this upper motion a bit more. It's more organic and cool. Now you could give it an attribute triangle, and to be honest, it's pretty much the same p scale as we did here. I want to have random p scale here. Let's call it p scale. And I want to have another particle system. And that particle system will be our particles from the mask attribute, right? In this case, we want to grab our mushroom. And not just the mushroom, I want to grab our mask attribute and paste it here. I want to go inside a pop network. Again, let's delete everything. Attribute delete. And as you can see, we have, I think it's shop material path attribute right here, which will give you some weird stuff in the preview. And if you delete everything on a primitive side, you can go back with the points. Right, go inside. And I don't need a pop. Maybe I could use it the same, but the main thing I want to change is source pop network. In the pop network, I want start into surface right and first right, and I want to use emission attribute as a mask. So that should work only with the, let's go back and back. So that could update our, if it's not working, you could always create a new scene, and that should help you. Right, let's go back and just kill this particles. Yeah, and it's working with the charm. So now what I want to do, I don't want to use this guy, and I don't want to update our velocity, but I want this position. I just want to follow the shape of the mushroom without using a collider, and it's great in this case. I could lower the threshold particles to be more or less out of the shape, and of course probably I could use it more to the down. I could use pop track, give it more of this liquidy style thing. I could use something like that, and in my case I want to lower these particles even more, so that will be a bubble, so you could see, and that will fly down. Let's give it more of this force down to see something at least right. And this very subtle motion, and to me, to be honest, both these particle systems is like giving your animation a bit of interest. It's not just simple bubbles. And now it's time, I think, to grab everything together. You could use a merge node just to see. And this is everything together at this point. We have particles flying away, we have bubbles, Vellum bubbles, and we have bubbles from particles, little particles, which will be smaller bubbles from this guy and from the mask itself. And I think it's cool. It's pretty cool to me. Right now you want to determine your camera, and I will use the same. And I will show you this rig. It's pretty simple. Camera 2. Let's go to the camera 2. First things first, keep position on parenting is on to my camera. Then you have this null for the position. Let me see, where is this? And this null is here. And I have the animation for the position from up to down. I think it's linear, right? And you have the rotation, you have the null in the same position, and at the same time I just separate the movement of the camera for these two nulls. So the rotation, doing only the rotation. Rotation is just panning when we have this moment, right? And to be honest, I could potentially disable this too. I could use our position node to have something like that in the movement. I need to kill this bubble, and I'll do it just in the moment, something like that. So we determine the initial position, alt click to the parameter, and we need to determine the end position, something like that, for example. And I have the auto keyframes on. The same is true for our rotation. We determine our rotation in the first frame. We need to determine our rotation at the last frame, right? It's not the right, something like that. It's already beautiful. So now you have your motion, and the pivot for your camera will be your nulls. So this will have nice point of view. It's not perfectly the same as we have, but the logic is pretty much the same. Then you need to tweak, you need to move it a little bit up. So you want to hide all these bubbles, but I grab the wrong one, so something like that. You could use your rotation as well, something like that. And for the last bit, I want to have this grass or branches swirling around, but I don't want to do it like very precise with geometry, and I decided to go with the planes and just cut it on the render time. It gives me pretty much okay result for this kind of stuff, and you can use it as well. So what you're gonna do, you create a planar patch. Planar patch is like the same as your grid, but you give it triangulated geometry, which is better for Vellum stuff. So here, give it a Vellum flatten, which is UV space, flatten your just UV coordinates. And I think what I hear is like moving your geometry. It's like weird stuff out there. I'm not sure what it is, but the main point is here to transform, press space 5, to transform it in this space of your one-to-one UV coordinates, because I have these maps. This is maps from some site out there. I could link it down below, and I want to grab this one. So I go inside, I cut this piece out of your map, and that will use as the opacity mask in my texture. And then you could use all kind of textures for the same piece. It's a diffuse, or maybe this is a diffuse one. This is specular, normal, bump, and so on and so forth, to roughness. So I transform that, go back to our view, do something like that, and I use a copy and just use an arbitrary numbers for the translate. To be honest, I just grab this guy and rotate it in the viewport so I could see the precise this stack. I could build a stack of planar. And the same goes here. I just use a Vellum cloth, right? And as well, as long as it's just cloth, I could give it a lot of stretchiness, but a little bit of bendiness as well. So Vellum solver. To be honest, I want to use this one to see what we got here. Right, I need to uncut that and go inside. I don't need to sort it anymore, but I want pop advect by volumes in my geometry. Right, and you have it. The last thing you want to do here is to take your mushroom geometry. sorry, control copy, and place it as a collider. And in this case, because it's like only to show you my approach, it's not the final, and I will use for the shader the final scene because it's like more predictable than this one. You want to play around with this a little bit more. So what you want to do is like to place your cards down there, maybe, and you need to see if your velocity field is grabbing these planes to work properly. Right, and it's cool. To be honest, it's cool. Now you have this motion. It's stuck with your grass flying away, and this is cool. And you could use it here as well to see everything updated, right? All right. Let's go outside of there, and I turn that off, and I will use my previously done simulation, and this is pretty much the same. I would say it's absolutely the same as the one we did before here. So the only thing I need to check if I did something else right. It's pop attract and pop advect by volume. And pop attract is like to give the general direction for these planes to attract this point, and that's it. Okay, and this is everything is cached and so on and so forth. And you could see we could dive into our texture for Redshift. Okay, this part for Redshift, go to your out content, create a Redshift rope. Main preview, I have two. Few things to do here. You want to change render frame range, and usually it's like if revert if start to finish. Then you want to go to your main. You want to determine your camera. For the output, you want to change the format and option for this. I just used JPEG, but if you use EXR, you could determine this here. You need to change the, for example, if I use EXR, you need to change EXR here as well. And if you save our animation, you need to use this $F4, which is the frame number for every final. Otherwise, it will save you only one frame. You specify your output link, and in here in post effect, if you save in an EXR and you want to have this control for manipulation the color on the post, for example, when you have this ACES control for the color, you need to turn that off. That will allow you not to bake all the colors manipulation inside of EXR. But again, I'll use a JPEG, and I want to see all my changes inside of my JPEG. Right, in the Redshift, you go to Advanced, go to System, again, change your bucket render to bucket size to bigger one. That will speed up your render for sure. If you have 2 or more graphic cards, it should be lower, I think, but you could experiment this with this number for sure. Sometimes it will give you just great boost in your render time, just changing these numbers. So pay attention to this. Also, when we go to IPR, when we just start your render, it's great to know that IPR plugin options, and you need to check that on, because by default this is off and you don't have the changes from your SOAP level to your render view. So sometimes it's weird and you need to update your render view every time you press the button, right? And it's not great. So be aware of this, not with this one. Under the Redshift, you go to Basic, sorry, Advanced. Okay, we already changed something here. Under Sampling, You could see I just used this number because I want to render that faster, but you could lower the threshold. The lower the threshold, the better quality you have, but the longer that will render. I'm using this motion blur as well for deformation, for instance. And in order to work that properly, you should go to, for example, grass animated, render Redshift, and under the render, you need to turn that on, mesh deformation blur velocity, and you have to add the velocity attribute. So under this guy, you should have this V. Again, you need to maybe to clean this up, but I don't care in this case. The same true for the bubbles, and so on. So going back to our render settings, that's it for motion blur. Global illumination, hard ray tracing, if available, it's RTX graphic cards will boost your render as well. For the global illumination, I used brute force and red and point cloud. Basically, that should give me a little bit of speed. I maybe should use the brute force bit first for the animated part, because this guy is like per render and blur some pixels and should give you some flickering. Could give you some flickering in the render, but it's okay to me for this purpose. You could dive that in their documentation for the Redshift, and that's it basically for this guy. Sometimes you are working with alpha background. Let me show you here, right? If you press it, RGB or alpha, and you're working with refracted surface, right? And you want to see that through on the post, and you want to place something behind. In this case, you want to go to legacy, I guess. Let me see. It's on the system for sure, and I think it's somewhere here when you are right. Refraction effects alpha channel. So you want to turn them on, and this way this object, refracted object, will not be just a solid alpha white. And it was a preview, so let's turn that on. Let's turn these two guys off, right? And let's use alpha, and you can see that alpha give me like this solid object is absolutely opaque. And if you go inside and go back to your system and turn that off, you could see your bubbles is completely we have no light, so you just see on that. Okay, it's completely not transparent. And if you want that for the post-production, you could check that on, sorry, and you could see that this alpha black is 0, so it's more transparent in this area. Great to know this feature, because I had some problem previously, to be honest. So that's it for all the render settings. Let's go to the material. And material safe is great. I could turn that on. I use material always gone with the lights, so I just used RS lights on, set it up like directional light, and that's it. I use RS light just to have a bit of backlight for this mushroom to see, to look like a bit more transparent. Let's turn that off. As you can see, it's like a bit of transparency out there. Okay, let's go for the transparent for the material part, and I don't need motion blur now. I want to see that more or less precise our objects for the mushroom. Okay, this it looks a bit complicated, but to be honest, it's pretty straightforward. What I did here, I have a model of mushroom, and I have all the textures, right? And I think it's somewhere there. And the texture is coming with a model, and if you could check that, show images. This is this one. It's pretty standard workflow for the grade model out there. So you have something like that, and you plug that in. So you could use a texture, just RS texture. And file name, specify here. Then you could, the only thing for this case you need to worry is RGB, which is color, and for the diffuse is great. Color as well. This is something like, I'm not sure, maybe it's OV. I make this too and use it as a diffuse color. And then for the okay, it's for transparency, reflection weight, I use the same. For the roughness, I use a raw number for the same picture, because this is a scalar picture, grayscale picture from 0 to 1, and I want, sometimes it's going with automatically, but I want to be sure that this is raw. For the roughness, I used to use a RS math range. It's like fit range in a pop-up. It's like taking the number from 0 to 1 and give you the range and more of a precise range to output. I could use a ramp, but the ramp is more of arbitrary numbers. Again, I use it as a reflection roughness, and for this guy, I use a mask, and I add this mask to our roughness. So I want to have more of a roughness material in the mask. In order to do that, you could just use RS point attribute, which will give you this sparkle attribute lookup node, and specify a few attributes. In this case, it's a mask, and you have a color, and you have its color number, and this attribute is basically on point level, I think. Then we have a bump. This is again pretty simple. I use different shades for the bump, for the normal map. As you can see, this is a normal bump map with a tangent space, and this is a height with a height field, because it's like black and white picture, and this picture is like blue, green, and red. I mixed that with the bump blender. I need to activate the adaptive mode and increase the weight for the layer number 0. It's a base layer, and layer number 0, by default it's 0. And if you want to work this properly, you want to activate this. Where I'm at, right? And for, it's like different maximum noise, additive, and that additive goes to another material. And this is our base material for the mushroom. And what I did here as well, I used subsurface multiple scattering to have this feeling of the light penetrating the material inside. I gave an amount, I gave some radius scale, and the radius is driven by our texture as well. So I have this texture, and I use it here as well. So this is pretty basic material for the mushroom. I create another one, and another one is just our sky material, snowy, and this is diffuse color of blue, reflection, and all this stuff. We have some refraction. I just compensate it with it. If you see, I get something like that. I gave it like an yellowy tone, and that will give me like a bluish tone inside. And I need to mix it somehow with our main material. So in order to do that, again, I just took our mask attribute, use a material blender, and blend between these two based on the mask. And mask is a black to white image, right? And it's not working. Sure. I need to turn that off, right? And everywhere we have this white, we'll have this material, because I'm used the mask for the blend for the color on the two, which is this one. And in the end, when we have mask, we have something like that. We need to update it. And why don't I see you? Because I have this flag here as well. And you see that our mask created by the solver is involved in our shader. This is how you could use your mask inside of your shader and mix in between two or more materials. And that is great. And this is gradually fade out from our surface. For the bubbles, I have a little bit of more, because as you could see, this is a bubble, and I took my bubbles, right? And this is one. I delete everything from every attribute from here. I gave it normal just for the good measure. And then I use a connectivity node. Connectivity node gives us an attribute. We could call it whenever we want, but I use a class attribute to the point for every connected primitive. So every connected primitive will have different values. So for every bubble, if we use a random from attribute, we have different colors. For this one, it could be 0.1, 1, 0.75, and so on and so forth. And every connected points in the primitive have share the same attribute. And this is cool for our texturing, because if we go inside of the bubbles, we could use this class attribute. Again, we use a particle attribute lookup, which is a rest point attribute, and we could fit range it to different numbers, right? We could change the range of this number, and we know that this is from 0 to 1. Again, from 0 to 1, we have different range of numbers, and this different range for numbers for the reflectance, or for the reflectance, for the roughness, for example. And you could see that this bubble is less rough than this one. The same is true for example, for something like a dispersion. I just change the input is the same, but the output is different. And the last thing is for our grass. Again, we just used a bit different approach here. If you use your material and you want to use your under the advanced tab, I think it's not under the overall, you have this opacity tab, and you have a lot of your leaves and so on and so forth. This opacity tab will be driven by this guy out here under your Redshift, and under your globals, this is transparency arrays, which allow to be shown in your viewport. So if this is too much, when you have, for example, a tree, this is not optimized way to use shader like this. So what I want to do instead, I want to use a sprite node, which is like this sprite, and you could find here. And under the sprite node, I linked to my opacity map that I have shown you, and I have the proper UV, and my planner is taking only this space under the 1x1 world space, right? And I use this as a mask to cut our leaves, right? And just before that, if we take that off, you have this planner, full planner. And if we cut this with a sprite, you could have as much grass as you want. You have the bunch of that, and you want maybe 100 of that, and that will work just fine. Again, after that, you could create a material before that, go use it as an input, and use all your familiar textures, give it more juice to your render, because out of the box it's just black material. You plug that in your RS material, and you use your diffuse, you use your roughness, you use your, in this case, translate color. I'm not using subsurface multi, but I'm using this backlight transparency with the weight and the color. Go into one, use your roughness and bump as well, and you have something pretty beautiful out of just a planar grid. And I think that's it. There's a brass, mushroom, and that's it that I wanted to show you in this case. So I hope you found it useful. That was a great one with a lot of different things involved which build this great stuff. And again, you could use it for your beauty shots, for the bottles, I think, because it has some cylindrical shapes. You could use it for whatever you want. For the magic, for the particles, for the vellum. Again, it could be involved with an RGB because it's like a point based simulation. Maybe flip could go as well. The same principle apply everywhere. So have a great day and bye bye till the next time, and I'm not sure why, but I will do something like that.